Hello, my name is Jamie.
And I'm Konrad, and welcome to our video demonstration of how to draw and label a galvanic cell.
The problem in question is number 2 in the electrochemistry notes.
And, just as a reminder, a galvanic cell is a cell that produces an electrical current via a spontaneous chemical reaction.
Now let's take a look at the problem. Calculate the cell voltage for the galvanic cell that would utilize silver metal and involve iron 2 ions and iron 3 ions. Draw a diagram of the galvanic cell for the reaction and label completely.
First, we need to break down the problem. We know that a galvanic cell involves a redox reaction, which is a reaction with a transfer of electrons. So we should look for the potential half reactions.
The iron ions look promising. If you write out the reaction in its reduction form, remember reduction is gaining electrons, then it would read iron 3 plus an electron goes to iron 2 plus.
Now it just leaves the silver metal. We know silver ions are normally 1 plus, so writing out the other half reaction in its reduction form would be Ag1 plus, add an electron, form Ag. Great, now we have two reactions.
Now we need to put the two equations together, but we want the electrons to cancel out. In essence, you want an electron on both sides of the equations. So we need to look at the half reaction potentials. This is where the standard table of reductions comes in handy.
So we need to look for both reactions on our table. The iron reaction has a cell potential of 77 volts, 0.77 volts, and the silver reaction has a potential of 0.80 volts.
So now, to combine the two reactions, we reverse the reaction with a lower cell potential, the iron one, and combine the two equations. So, you would reverse this one, so it would become add it all together, and you would end up like this. Notice how the electrons cancel out.
And to find the galvanic cell potential, it's really simple. You just flip the sign of the equation you flipped and add the two potentials together. So you get a cell potential of 0.03 volts.
So we flip the iron one, so then it becomes negative 0.77 plus 0.08, which will get you the 0.03 volts. So that's one half of our question done now.
So now we have to determine which metal belongs to which electrode. The anode is the place of oxidation, and the cathode is the place of reduction. So going back to our equation, iron is oxidized, and the silver is reduced.
We know this because, taking a look at our mnemonic device, oil rig, oxidation is losing electrons while reduction is gaining. So if you look back, our silver goes from 1 plus to neutral, so it's gaining an electron, therefore it is reduced. And the opposite is true of the iron. So to start drawing it, you want to draw your two cells and draw two generic electrodes in with the solution and the wire connecting the two. So, as Konrad said, the metal that is oxidized is the iron cathode, so you want to label this Fe2+, and this will be anode. Moving to the other side of our drawing, you'll see that the other metal left is silver, so you want to label that Ag, and you also want to label that the cathode. A good way to remember how which electrode is which is to use the mnemonic device again. Is it anox and red cat? Now, the way to do this is the anode is where oxidation occurs, and the cathode is where reduction occurs. So that's just an easy way for you to remember how it goes. And then the next part is you want to draw the electron flow from each electrode to the other one. So for this, use the mnemonic device fat cat. From the anode to the cathode is what it stands for. So you go from the anode, so you want to draw electrons this way. So that's how that goes.
Also, you need to draw a salt bridge that connects the two. A salt bridge ensures that there isn't a buildup of charge in either compartment so the cell can function normally. You needn't label it, rather just draw it.
And that's it. You can now draw a galvanic cell.